An AI assistant has produced one small function. At first glance, it looks plausible, but before it enters the codebase, it has to survive 4 separate reviews and a test gate. So, would you ship it? For this exercise, we're deliberately not inventing an implementation. There's no hidden defect, benchmark, or test result waiting for some dramatic reveal. Instead, we're examining the review process itself, the questions that turn plausible-looking output into an informed decision. Those 4 reviews cover correctness, performance, simplicity, and maintainability. After that comes a safety gate, generating and running tests alongside the function. Each stage examines a different quality, and that means no single stage can stand in for all the others. Keeping the unit narrow really matters here, especially for beginners. A single function gives you a manageable space where you can study syntax, recognize common patterns, request explanations, and identify exactly what still isn't clear. The goal isn't to reward code just because it looks complete. The goal is to understand it well enough to decide whether the evidence you actually have supports shipping it. The first review starts with the most basic question of all. Does the function actually do what it's supposed to do? Before you try to answer that, state the intended behavior in plain language. What is the function responsible for? What's outside its responsibility? What inputs and outcomes should the reviewer expect? Without that reference point, readable code can seem convincing, while its actual fitness for the job remains unresolved. Next, walk through the generated code carefully. Ask the AI assistant to explain it, and then ask again anywhere the explanation still isn't clear. Have it unpack unfamiliar syntax, describe the role of each part, and connect the implementation back to the intended behavior. Repeated explanation is useful here because a polished first answer isn't the same thing as genuine understanding. For a beginner, one rule needs to stay firm. Don't use code you don't fully understand. If you can't explain why a section exists or how it contributes to the function's purpose, then correctness hasn't been established. That isn't proof that the code is wrong. It means the review still has an open question, and an open correctness question blocks a confident decision to ship. The second review asks whether the function does its work reasonably or whether it introduces avoidable cost. This review should remain proportional to the function's narrow scope. Trace the work the code performs, step by step, and ask whether anything seems unnecessary or repeated. The goal isn't to invent a benchmark or demand a clever optimization. It's to understand the approach well enough to recognize where cost could come from. Ask the assistant to explain the performance characteristics of the generated approach in terms you can verify by looking at the code. Which operations are doing the work? Does the function repeat any work that could be avoided? Is the approach reasonable for its stated responsibility? And if the explanation relies on an assumption, bring that assumption into the open instead of quietly treating it as fact. A function can be correct and still need revision because of performance. The reverse is important too. An approach that looks efficient doesn't establish correctness. Keep those dimensions separate. At the end of this review, record one of 3 conclusions. The approach is understood and reasonable. A specific concern needs revision, or there isn't enough information to judge. Uncertainty is a perfectly valid review result. Silently turning uncertainty into approval isn't. The third review asks whether the function is harder to understand than it needs to be or whether unnecessary complexity is hiding somewhere inside it. Go back to the plain language description and compare it with the actual structure of the code. Can you follow the path from input to outcome? Can you connect every part to the function's narrow responsibility? If the implementation feels much harder to explain than the task itself, stop and ask why. This is a good place to use the assistant as a tutor. Request a line-by-line explanation. Ask which concepts or language patterns are being used. Then ask whether the same responsibility could be expressed more clearly. The point isn't to demand a complete replacement by default. It's to expose the choices in the draft so that a human can evaluate them. Narrowly scoped work is especially useful during this review because it gives learners room to absorb syntax and common patterns without losing sight of the function's purpose. If repeated explanations still don't make the code understandable, don't ship it simply because it appears sophisticated. That doesn't prove the implementation is defective. It shows that the simplicity review hasn't cleared it for use by this reviewer. The fourth review looks past the present moment and asks, could another developer safely understand and change this function later? Maintainability starts with comprehension. Can a reviewer identify the function's responsibility without having to reconstruct a much larger system? Can its important choices be explained? If someone requested a future change, could a developer locate the relevant part and reason through the consequences? Ask the assistant to explain the code as though it's teaching the developer who will maintain it. Then challenge that explanation. Which details are essential? Which assumptions have to remain true? What would a developer need to understand before changing the function? The generated explanation isn't proof on its own, but it can reveal questions that the human review still needs to resolve. This dimension overlaps with simplicity, but the two aren't identical. Simplicity asks how easily the implementation can be understood right now. Maintainability asks whether that understanding can support safe changes later. If the current reviewer can't fully explain the code, handing it to a future reviewer doesn't make the problem disappear. It only transfers it. Until the function's purpose and its choices are understandable, maintainability remains an unresolved gate. Now it's time for the 4 reviews to meet evidence. Generate tests alongside the AI-produced function, inspect those tests, and then run them. That creates a safety gate that can catch implementation problems early, before the function disappears into a larger code base. The test should challenge the intended behavior, not simply mirror the generated implementation. Start by restating what the function is supposed to do, then connect each test to a specific part of that expectation. Ask the assistant to explain why every test exists and what kind of problem it could expose. And just as with the function itself, don't rely on test code you don't understand. A failing test gives you actionable evidence. Either the implementation, the test, or the stated expectation needs investigation. A passing test is useful evidence too, but it isn't a universal certificate. Passing tests alone don't prove correctness, performance, simplicity, or maintainability. They provide evidence only for the cases that were actually examined. That's why this stage is a gate, not a substitute for review. The strongest decision combines human understanding across all 4 dimensions with test results that genuinely challenge the intended behavior. Now it's time for the verdict, but there's an important limitation. The supplied findings don't contain an actual function, implementation, benchmark, defect, or test result. So an honest review can't declare this particular function ready to ship, and it can't invent a reason to reject it. The evidence here supports a decision process, not a fictional outcome. Create a small decision record. For correctness, performance, simplicity, and maintainability, mark each dimension as cleared, revised, or unresolved. Then add the outcome of the inspected test gate. Ship only when the human review clears all 4 dimensions and the test evidence supports the intended behavior. Withhold the decision when either understanding or evidence is incomplete. Pay attention to the standard being applied here. AI-generated code is treated as a draft that requires human review before use. It isn't rejected simply because AI generated it, and it isn't accepted just because it looks finished. The verdict follows what the reviewer can explain and what the available tests can actually challenge. Without those inputs, in this case, the responsible verdict is clear, not yet cleared to ship. Here's the reusable checklist you can apply to your next generated function. First, Start narrow. Give the assistant one manageable unit so you can study the language's syntax and common patterns without surrendering the entire problem. When it's appropriate, configure the assistant as a tutor. Ask it to teach the concepts without supplying complete solutions. Then, work through the 4 reviews. Correctness. Can you connect the implementation to its intended behavior? Performance. Do you understand the work it performs? And does the approach seem reasonable? Simplicity. Can you explain the code without unnecessary confusion? Maintainability. Could another developer understand its responsibility and change it later? Whenever an answer isn't clear, ask for another explanation. And keep coming back to the central rule. Don't use code you don't fully understand. Finally, generate, inspect, and run tests as a safety gate. Treat failures as prompts for investigation, and treat passing results as evidence with limits. Tests strengthen the review, but they don't replace it. The final decision has 3 useful outcomes. Ship when every dimension clears and the tests support the behavior. Revise when you find a concrete concern, or withhold judgment while important questions remain. That's the practical shift. Generated code is a draft, and understanding is part of the acceptance criteria. If this 4-part review gives you a better way to judge generated code, subscribe to Neural Stack and tell us in the comments which review dimension catches your attention first.